Hi, my name is George Wilson, and I wanted to spend some time talking about a new feature called Dynamic LUN Expansion within ZFS. So before I go into what Dynamic LUN Expansion really is, I kind of want to give you a little bit of background on how we actually do space allocation within ZFS and some of the various naming conventions that we use. So ZFS is comprised of what we refer to as virtual devices, or VDEVs. Anytime that you create your storage pool, you're actually creating it based on a collection of a bunch of virtual devices. Now, these virtual devices can be of two types. They can either be a physical virtual device, something like a disk. You'll also see some literature where we refer to those as leaf devices. Or they can also have logical devices, which would be things like any interior VDEV, a mirror, for example, a RAID Z. Those would be considered logical virtual devices. Now, the way that these are arranged within ZFS is they're actually arranged as a tree structure. And I'll show you a little bit more about that here in a second. But each one of these trees always has a very special logical device that we refer to as the root. So you start off with a root device, a root VDEV, and below that you can have interior or physical devices that kind of stem off of it. It's also worth noting that any direct children of the root have a special name as well, and they're referred to as top-level VDEVs. So they may be an actual physical disk, or they may be an interior VDEV, such as a mirror. The way that ZFS actually uses those top-level VDEVs is those components are the allocatable pieces of ZFS that actually make up your pool size. So I just want to kind of draw up an example of what I mean by this. So if this were my root VDEV, and I wanted to have a pool that was actually comprised of two sets of mirrors, I would have directly below the root two interior VDEVs that would be of type mirror, and those would be comprised of at least two physical devices. So again, for our terminology here is we have a root VDEV, two mirror VDEVs, and each one of these are considered, or actually everything in here is considered an interior VDEV. And then below the mirrors, we actually have physical disks, and these are our physical VDEVs. And these are all comprised of a certain size. So just for the sake of our example, we'll say that these are 500 gigabyte drives. So the way that the accounting would work here is that each mirror would look at any physical devices that sit below it to determine the actual allocatable size of the mirror. In this case, because it's comprised of two 500 gig drives, it makes this mirror a 500 gig mirror. Now, I mentioned earlier that there's a special naming convention for any VDEV that sits below the root. These are referred to as top-level VDEVs. It's the top-level VDEVs that actually are used when we talk about doing things like allocations and actually figuring out how we distribute space. So in this case, we have two top-level VDEVs, which happen both to be mirrors. So we said all of these are 500 gig. Which means that for this particular pool, I'm talking about a terabyte pool. I simply sum up the space of each of my top levels. That gives me the approximate space of my entire pool. So when we want to talk about dynamic LUN expansion, we have to realize that I just simply can't expand one particular leaf VDEV in this configuration because it won't actually give me more space. For example, if I took this disk and simply replaced it with a terabyte drive, the mirror would look at this and say I have a terabyte drive and a 500 gigabyte drive. I take the smaller of the two, which means my mirror is still really 500 gig. I didn't do anything. I didn't actually accomplish what I was hoping for. I didn't make the pool larger. So in this example, in order for me to actually expand the pool, I would have to expand the drives below the mirror to make the top level actually get larger. So in this example, if I just simply wanted to make the pool grow, I would take these two drives out, replace them with a terabyte each, making this mirror a terabyte, making my entire pool a terabyte and a half. So that's easy to understand when we're talking about physical disks. Now when we start talking about LUNs, the same thing holds true. I can go back to my back-end storage array, increase my LUN size from 500 to a terabyte, but I would have to do that for all the LUNs associated with the mirror. Now, what Dynamic LUN Expansion has allowed us to do is that we can now interact with the SCSI disk subsystem and get a notification back whenever a LUN has expanded. And based off of that, whenever we see that the LUN expansion event come through, we simply reanalyze the pool and determine, did the pool actually grow? So the way that this is all kind of fits together is we tie into the SCSI disk subsystem. Whenever a LUN, a storage array, is actually able to grow a LUN, it will send a SCSI check condition which will be received by the SD driver. The SD driver will simply look at it, determine that there has been a change in capacity. It will then send a sys event using the sys event framework to a command within ZFS called ZFS DLE. Now this is its whole purpose in life is to simply listen for these types of events and notify ZFS that there has been some kind of change. So whenever ZFS DLE receives one of these events, it will call back into the ZFS library and say, I need to go re-inspect the actual configuration of the pool. From there, we will then go back into the kernel code of ZFS, and it will look at each one of these devices and determine that this particular device was the one that actually expanded. Did that make a change to my top level? And if so, make the pool larger. From a high-level view, it's actually a very simple process of simply getting the notification back and simply processing it through ZFS to determine if that has actually changed. There's a diagram that shows how this entire process flows together. So you can see that we actually will receive the event, call back into the kernel, we'll reopen each of these VDEVs to see if they have been updated for size, and if so, then we expand the pool. We didn't want to have this feature enabled by default because we felt that, administrators out there may actually be making changes on the back end but don't necessarily want to change the size of the pool. So we introduced a new property which is called auto expand, which can be enabled at a pool level. You simply use the zpool command to set auto expand to on, and at that point in time, anytime a new check condition comes in for a LUN expansion, it would automatically grow the pool if it's capable of doing so. Now, you may want to have finer grain control. Rather than setting this to on, you may actually want to be able to contact your storage administrators so that they grow the LUNs on the back end, and you as the system administrator can then take charge and actually expand the pool by using an individual command. That's what we refer to as the manual LUN expansion. So what we did is we added a new option to the zpool online command, which is the -e or the expand option, which allows you to actually specify a particular disk that you're interested in expanding. So again, for this example, I could simply do a zpool online -e of my pool, specify this device, and then if this device actually caused the pool to grow, then we would grow it. Now, when we're talking about this example, if I had actually expanded these two devices, I would have to run the zpool online -e command twice. Once for the first disk, once for the second disk. That would allow the top level to actually expand. My pool would grow in size. So that's the general premise of the ZFS Dynamic LUN Expansion. It's worth noting that as a result of this project, though, we did make some changes to provide a little bit finer grain control about how devices grow in ZFS. It used to be the case that you could simply replace a given disk with something larger, and once the replace or the resilver completed, it would grow the pool. That was one way that users were increasing the size of their pool simply by replacing disks. Unfortunately, with the auto expand, option now, that no longer happens. You have to explicitly say, I want to grow the pool. The main rationale for that is we wanted to prevent cases where you may have inadvertently replaced it with a disk that was larger, and now all of a sudden your pool got bigger, but then when you realize the mistake, you can't actually shrink it back down. So by making this an explicit command, it prevents those types of errors. So you may want to be aware of that going forward, you have to manually explicitly say, I want to grow the pool. Another added benefit that we got from making these changes to the way that we handle all the accounting is that it now gives us the flexibility of being able to change the sizes of the disks that comprise the top level and still allow them to attach. So for example, in this case, I may have gotten 2 drives from 2 different vendors. One that tells me it's 500 gig, the other one also claimed it was 500 gig, but when you actually look at it, it's not truly 500 gig. It might be 496 gigabytes. Well, if I try to put those two together and make a mirror, in the past what it would say is, these devices aren't the same size. Now, with the new logic, we actually look to determine, based on the physical sizes, is the disk capable of having the same amount of allocatable space that would allow me to make this look like a 500 gig disk. So the way that we do that is we actually look at the individual devices and we know how many allocatable segments or slabs are on that disk. If they both match, regardless of their size, we allow that device to be attached. So it gives us a little bit more flexibility and allows us to deal with the way that vendors decide to do their space accounting or advertising or marketing for their disks. So that concludes the LUN expansion feature for ZFS.